All right, so today we're going to look at pyramids. A pyramid has one base, which can be any polygon, and then it has the number of lateral faces equal to the number of sides of the base. In this case, we have a square base, so we have 1, 2, 3, 4 lateral faces. From the base, the lateral faces angle upward, and they intersect at this apex, which we call the vertex of our pyramid. So we have one base, we have lateral faces equal to the number of sides of the base, and opposite the base, the lateral faces come together at a vertex. Now, because the faces come together at this point, each of our lateral faces is a triangle. Now, in addition to the base, we have the height of our pyramid, which is simply the segment that goes from the vertex to the center of our base. So the height of our pyramid, in this case it's 8, and our base, we're going to say the side is 12. Now, because it comes down to the center, we know from previously from polygons that the segment from the center to the midpoint of a side is the apothem. So, all familiar terms. We've got our base, we've got our vertex, we've got our lateral faces, we've got the height of our pyramid, and we have the apothem. Now we have one additional new measure, which is this segment that goes from the vertex down to the center point on a side. And this is what we call the slant height. And we're going to use a cursive L to represent it. Now these three together, our apothem, our slant height, and our pyramid height, form a right triangle. We can see it here, and we've taken it out right here so you can see it outside the pyramid. Now, because they form a right triangle, if I know the pyramid height and I know the apothem, which I can get from my side length, then I can find my slant height. And if I know my slant height and my pyramid height, I can find my apothem, and so on. Now, in this case, in our example, our pyramid height is 8. Our base is 12, therefore the apothem is 6. And if we did Pythagorean theorem, a squared plus b squared equals c squared, so 6 plus 8 squared equals c squared, 36 plus 64 equals 100. So the square root of 100 equals c, so c equals 10. So our slant height right here is 10. And the reason we need our slant height is if we see it's going from the vertex to the center of the side, so it is the height of this triangle lateral face. So we need the slant height to find the area of this triangular face. And then we need the height here to find our volume. So when we're looking at our pyramids, we need 4 pieces of information that we'll be working on today. We need the area of the base. So in this case, it's going to be 12 times 12, or 144 units squared. We need the perimeter of the base. So if we have 4 sides and each side length is 12, 12 times 4, so 48 units. We need the height of the pyramid, which we were given, so 8 units. And then we need the slant height, which we found, 10 units. And with these pieces of information, we can now find, just as we did with the prisms, the lateral area, the total area, and the volume. Now the lateral area in this case is equal to the perimeter times the slant height divided by 2. So our perimeter, 48. Our slant height, 10, divided by 2. 480 divided by 2. 240 units squared. And if we look at this, all perimeter times the slant height divided by 2 is the formula of the triangle for this triangular face, this triangular face, this triangular face, and this triangular face all at once, because the perimeter is simply each of these triangular bases. Now our total area is very simply the lateral area plus the area of the base. So area of the base, 144. We already have our lateral area of 240. So 240 plus 144, 388 units squared. And last but not least, our volume. Our volume is going to be equal to the base times the height divided by 3. So area of the base we have is 144. So 144. Our height we have is 10 divided by 3. So that's 1,440 divided by 3, which equals 480 units cubed. So we have our pyramid, the 4 pieces of information we need: area of the base, which is simply the area of that polygon; the perimeter of the base, which is simply the sum of the side lengths; the height of the pyramid; and then the slant height. Again, the new measurement going from the vertex to the center of the side. Now, the pyramid height, the slant height, and the apothem form a right triangle, so we can use 2 of the pieces of information to find the third. Once we have the base, the perimeter, the height, and the slant height, then it's a simple matter to find the lateral area, the total area, or the volume.